Alright, so this video is going to be short and sweet. We need to talk about carbon and nitrogen cycles. So when we say cycles, we actually mean a circle that kind of goes around and feeds back into itself. You could compare it to the water cycle, where water basically feeds all the way around from clouds all the way down to the ground, evaporates back up, and completes the cycle all over again. The only difference is we need to look at carbon, how it does it, and nitrogen, how it does it. So let's look at carbon first. Carbon's a little simpler. First of all, we need carbon to be able to get all the way through all these steps. The reason being because we need C to make all of our biomolecules. Cho-cho, chon, chomp all have C. Carbs, lipids, proteins, nucleic acids. Without the C in any of these steps, you cannot make the biomolecules, which means you can't make the molecules of life, which means you can't make all the fun stuff. So let's just follow through where carbon is. I always kind of like to start here in the atmosphere. That's where most of the CO2 resides, and that's where we start our cycles for the most part, atmospheric carbon and nitrogen. CO2 is brought down to the plants through photosynthesis. CO2 is a reactant of photosynthesis, so we know that the plant needs it in order to do its job and make glucose and make plant things. Chloroplast will pull the CO2 down and it'll help process it. So we have this happy plant. Unfortunately, his entire existence is basically to serve two purposes. It's to get eaten by the cow or to die and become dead stuff. In either direction, the carbon will go with it. That means the cow would get the carbon from the plant, or the carbon would go down into the ground. It would just be a dead plant. Now, also the cow can die. So, there you go, dead cow. The next step is what the cow does if it doesn't die. Every time you breathe out, you're breathing out CO2. Alright, so Mr. Cow breathes, he breathes out, CO2 goes back to the air, and you already kind of started back over in your little cycle. Remember, it's all trying to feed back into the next step. Whereas, if Mr. Cow dies, or the plant dies, they're decomposed down here. Stuff like mushrooms and worms and all kinds of decomposers. They're actually going to break down all the biomolecules in the dead stuff, releasing the C's, the H's, the O's, the N's, the P's, all that fun stuff. Over time, those guys are going to sink down into this thing called a carbon sink. Duh. This is fossil fuels. This is coal, oil, peat, natural gas. We call them fossil fuels because this takes millions of years. So we're burning basically old dinosaur biomolecules. We burn it in our cars. The cars use it for energy. And then one of the products is more CO2. This is normally going to be good because you get CO2 back in. The problem is, if you're chopping down this guy, the plant, that means he's pulling less and less CO2 out of the air. And you're building more of these guys, cars, you're putting more and more CO2 into the air. So you're going to have this giant angry buildup. Basically, that's global warming. That's the greenhouse effect. You have a buildup of CO2, and the imbalance caused by humans is going to mess it up. So deforestation jacks up the right side. Burning of more fossil fuels, whether it be in cars or factories, jacks up the left side. If either side gets messed up, it's going to create an imbalance because the cycle wants to be all chill and balanced out. That's the carbon cycle. Nitrogen cycle looks more complicated, but it's really not. It's the same thing. We need nitrogen. It's not in every biomolecule, cho-cho, chon, chomp, but it is in two. Chon, proteins, chomp, nucleic acid. We're going to start in the atmosphere again and get down in two ways. He can get fixated. Basically, nitrogen fixation is going to pull nitrogen out of the air. Photosynthesis doesn't use nitrogen, so we can't just yank it out by normal plants. Lightning also is going to help bring some down. It's just not as predictable or dependable. Nitrogen fixation is going to take this nitrogen and put it in a big pile, and we'll get to that pile in just a sec. If a plant gets eaten by the cow can do two things. The cow can basically use it to make his proteins, nucleic acids, and then eventually get rid of it in waste or death. Then our decomposers do the same thing. So now we're back into this little trash can, the bottom left. It's called unusable nitrogen. This is ammonia. It is nitrogen, but it's not in a form that stuff can use. So this little green guy with the little spikes is a bacteria. He's going to nitrify it. Nitrification turns ammonia into nitrites and then to nitrates. You don't have to dwell on that part, you just have to know that it's usable. So basically unusable, trash can, usable, up here. Now that it's usable, plants can grab it, and then plants go on their kind of sad little lives of either getting eaten or dying, which puts them back in the cycle. There's also some bacteria up in the top that can convert back into a gas. It can actually take nitrogen from this usable pile up in the top left and bring it back to the atmosphere. Same thing like carbon cycle. If something gets jacked up, the cycle is going to get broken. Let's say this guy over on the left, something happens to this bacteria, dies, it explodes, I don't know, whatever. Just assume he was in a Michael Bay movie where everything explodes. So now he's dead, which means I'm stuck with a giant pile of unusable nitrogen. It's going to keep building up because I cannot convert it up. So all of it is going to get kind of stuck behind the broken part in a big pile. If you have a disturbance in the cycle, it can't move forward and it can't cycle all the way through. We want to get over here, up in that top right, back to the atmosphere. But if I get stuck as unusable nitrogen and I can't convert it, it's going to cause problems. Ammonia, like if you have a cat and you don't clean the litter box because like you're a teenager and you don't do your chores and that's like your thing, it smells really strong, like a sour ammonia smell. That's basically nitrogen. Now, if you were to compost their waste, eventually there would be enough bacteria in your compost pile to kind of convert it. That's why you can throw coffee grounds and eggshells and banana peels into a pile and kind of mix it around and make it into kind of a fertilizer, which is what they do. That's what a compost bin is. But the whole point is that I need to get nitrogen and carbon back. My cycle needs to be able to go all the way around in a cycle and not get too jacked up. It needs to find weird pathways to do it, but it needs to figure it out. Same thing with carbon. It's got to find a way around the cycle. It can jump around and take a couple different routes, but if it doesn't, the carbon doesn't get to where it needs. And if I can't get carbon and nitrogen, I can't build any of my biomolecules, which means I can't build any of my stuff of life. So all my stuff's going to end up dying. Then if all my stuff ends up dying, then it's, I don't know, that's bad, right? Don't need to explain why that's bad? It's bad. Stuff can't die. Don't let stuff die. Don't cut down all your trees. Also buy solar panels. I don't know. Tweet at Elon Musk. Ask him to give you some. He'll probably figure something out. But you have to send him a dank meme because that's apparently the only way he replies. So, yeah, go do that. That'll be fun.